Hello. Today, I hope you're excited because you're going to run your very first hydrodynamic model. And by hydrodynamic model, I do not say a run-up model, one of those empirical models that you can do very easily, but a proper full mathematical model, allowing you to calculate waves along the coast or to understand coastal erosion in different scenarios. What we're going to do in this tutorial is to show you how to set up the very basic model and to get the very basic stuff that you need to actually run it. In the next tutorials, I'm going to show you how to improve it a little bit and then how to run it and how to evaluate the results. So without further ado, let's have a look into what we're using. What we're using is called XBeach. XBeach is a model developed by Deltares. It's completely open source and it's basically something that is highly used into different settings in coastal engineering, coastal geology, coastal geomorphology to basically understand how waves are modifying the coastline during storms. So this is done for storm modeling. It can also get used for tsunamis, but this is not what we do. If you go here to download, it will ask you to log in, so you should make a username and password. It's free. You should register here, and then you will be redirected to the download page, and you will be able to download XBeach. The version we're gonna need is XBeach 1.24. We should be at Halloween Win64 in my case. And important, you should select a version that gives you a netcdf as an output because we're going to use that as an output. The second tool we're using is called Delft Dashboard. It's also produced by Deltares, which is a company in the Netherlands. It's also open access, and it's a tool that basically allows to make quickly a grid and a bathymetry, so you don't have to fiddle with more complicated things. So you go on the website, it's linked in this video tutorial, and you download the Delft Dashboard. Now, I already downloaded it, it's in my desktop. You unzip it, and when you unzip it and you open it, this is what you get. You get a folder with two subfolders. One is called bin, the other is called data. So if you go into the bin, this is what you find. That's basically the executable that you will have to double click, and this will appear for you. So this tells you that the program started. It takes a few seconds to get going and running, but you see things are appearing here. A logo is going to appear. You probably don't see that because it's in the other screen. But as soon as this is over, we will be able to start digging into it. Okay, now that it's all over, you have this screen in front of you. This is basically a world map. As you can see, the GEBCO bathymetry and the SRTM topography. And from here, we will start our journey into creating the first model. So the first thing we need to do is to change the coordinate system. XBeach works with UTM coordinates. It means that we need to give it a grid which is in meters. So we select the UTM zone. It tells us that all model and toolbox input will be discarded. And yes, we do continue because there's no toolbox inputs. And this is what you get. So you get a map where you can basically select a UTM zone. For this model, let's do something down in Florida. Let's go down there. And let's see what happens when I change my coordinate system. It takes a second. You see that my computer is still thinking about it. Good. Now we are basically getting down to Florida. Okay, now let's select an area where we want to have some, where we want to do some modeling. I would say let's go down to the southern part of Florida. We might want to model something in this area. It takes always a little bit to load things, but you see that in the end things are basically going on. Now this visualization is a little bit poor, so we would like to maybe go to a hybrid version. So you go to view, and then you can select which kind of visualization you want. So we go to the hybrid visualization. Let's see. It should open up a map, which is basically a satellite map with data. Again, you need to have lots of patience. We are in the Cape Canaveral area. It's not too bad. So let's zoom in a little bit, maybe in this area, exactly here down to Cape Canaveral. You see that it always takes a little bit. The keyword is patience here. You don't need to reload. This is a bit of an old software, but it works. So let's not give it too much rush. So let's say I want to model a part of this beach. Usually you should select in XBeach a just a part of a beach. It's for small areas, otherwise it will take a long time, and it's not very very good in very large areas. There are other tools, other models that can be used. You should think about different approaches. But you know, for a small beach, for a small area, this is actually pretty good. So let's have a look at this area around here. I kind of like it. Let's keep this area as our target. Now, the next thing we want to do is to first of all select our working directory. So I go to File, select working directory, and this is basically allowing me to select where the data is going to go. I created a folder before, example XBeach, so I can select this folder. And now I know that everything I do will go into that folder. So everything I'll do here will go into that folder. Great. Now, let me go back. Now that we chose our area, let me switch back to the bathymetry, visualization, so I can visualize the bathymetry. You see here, this is pretty rough. This is pretty rough because this is the GEMCO bathymetry on an SRTM data set, so it's pretty, it's not very good. But what can I do? I can go to bathymetry and look for, as I am in the US, the coastal relief model. This is a bit of, actually a much better bathymetry, which was realized by the NOAA for flooding purposes. So it takes a while. Again, you have to wait, you have to be patient, and you'll see that stuff will come out. This is a little bit better. So we get something decent out of it, something better out of it. Very nice. So, well, by the way, now that I'm here, there is also the way to insert your own bathymetry. So if you go to Toolbox, then you go to Bathymetry, you can basically import your own bathymetry into from different formats: XYZ, NetCDF, MetFiles, ASCII grids, or GeoTIFFs, etc. So if you have a topography and a bathymetry of your study area, you can import it here. But for this example, let's gonna stick with what we have. Okay, so we selected our working directory. Let's check. It's example XBeach. That's fine. Now I want to model with XBeach. You see that here there are a number of models that Delft Dashboard can actually help you build, but I'm going to select XBeach, and you see that down here something has changed. Okay, now we will dig into it and we will start looking into that. Before that, let me go back to the hybrid map so I can see where the beach is, what I want in my model. Okay, this is what I would like to have. Let's let's do something crazy here. Let's go here. So we can also try to model this area. Okay, I'm gonna put myself into this area. It's a little bit diverse. You have a channel. I suspect this is an artificial channel from this John Kennedy Space Center. So this is a famous place. Okay, so again, patience. And this is what you get. You see nice waves breaking on a shore, and then you have some buildings, some stuff in here. Good. Now we put our attention down here. First, we wanna have a grid size which is good for this kind of beach. I would say 10 meters. This is the minimum grid size in the X direction and the minimum grid size in the y direction. Okay, so this is the minimum grid size in the areas where you actually want to model the waves really well. Let's say that if you go offshore, you might not want such a good one, such a high resolution. So this is the maximum grid size in the y direction. So this is 50 meters and 50 meters offshore in the x direction. The area we are interested in is about, let's say, 70%. So this means basically that 70% of your area that we will draw on the map will actually have a very high resolution. So we'll actually have those 10 by 10 meters resolution. Okay. Now, I can start drawing the grid outline. So I go here and I draw the grid outline. This means that you have to basically make a rectangle, something like this. Right-clicking, you can tilt it a little bit to follow the shoreline. This is something which we can do. Now, there is one thing you have to wait. I will go back here. When you click on draw grid outline, it tells you that you have to make sure the origin is offshore and the coastline is at the right. So let me show you what it means. The origin is this yellow dot, and the origin must be offshore and the coastline must be to the right. Let's remember that for a second. Okay, so I'm gonna do something like this. Okay, this is not offshore, so I need to bring this offshore. So I need to rotate my grid and readjust it until this. I might have to zoom out a little bit until this one. Again, be patient. Until this one is, the yellow dot is offshore. So I'm gonna adjust it till I make it. Now I know that I went a little bit crazy, but this is it. Okay. The yellow dot now is offshore and the coastline must be to the right. Now, this is something it takes a bit to understand, but how I understand it, or how I put myself in the condition to know that I did everything right, is I sit myself on the yellow dot. I'm offshore, I sit on the yellow dot, and I look at the other dot that there is offshore. If looking at the other dot offshore, the coastline is to the right, then I did it okay. Otherwise, I have to flip the grid. This is because XBeach expects to have the origin in a specific point. Otherwise, it will not work. Okay, so here I am on the yellow dot. If I imagine sitting and looking at this other dot, the coastline is to the right. So I know that I did it all right. Let me refine it a little bit. You know, I can refine it just a little bit, just not to have a lot of area. We don't want to have a lot of area. Nice. Now we drew the square in which the grid will be drawn, a 10 by 10, a 10 by 10 meters grid, which should work out well. Now down here you have the hydrodynamic or the boundary conditions from which the hydrodynamics are concerned. So storm surging meters, significant wave height, peak period, time. We could make it rounded to 1 hour, so we have 1 hour of waves, and then we have theta min and theta max, which are set already when you do the grid. If you turn it, these will change. So let's not touch them. Okay, you don't touch these two. Wave direction is the direction from which the waves are coming. Here you have this very interesting button, which is called Retrieve Fast Boundaries. A few years ago, Deltares made a database of 1 in 100 years time return period swells for all around the world. And if you click on this, you will go onto the database and you will basically get those data. So if you click a retrieve on fast boundary, these values have changed. So storm surge level is 1 meter, significant wave height is 5 meters, period is 13 seconds, and then the wave direction is 107 degrees north. So this is the north is going to be something from this direction, coming almost perpendicular to the shore. Good. So we drew the grid outline. Now, before we make the grid and model, which is our last step, let's have a look at here. What I want is a bathymetry. I told you that you can insert yours, but here we can use the NGDC coastal relief model, which is good. So we select it and we use dataset. Now it's going to be taken into account when we click on this. And then we have a number of tabs up here, which I'm going to go through very quickly. We're not going to use them, but I'm going to tell you a couple of words, because this is a very first model, but then everything will open up once you start looking into it and working with it and just changing different things you want to do with this model. Okay. So for which concerns the physics, well, it's asking you what to include: short, long wave, the flow, the sediment transfer, morphology, and avalanching. You see that it's all turned on, so it's fine. This is the physical constraints, the gravitational acceleration and the density of water. Don't change it unless you know what you're doing. Maybe for very muddy waters with sediments. The time of stop is 1 hour, as we said it, and the current Friedrichs-Lewis number is 0.7. Leave it as it is. Then you have the wave input. This is basically everything that you would change if you wanted to change how the waves are modeled in your model, but we're not going to touch it. And the flow as well, if you have something like a tsunami wave coming in, or a flow of water, or a current of water, a tidal boundary condition coming in. Here we're not modeling the tide. You can insert it here. So you have the availability of tidal flow, water flow transport. Then you have the sediment input, which is another bunch of how to say, it's another bunch of options. That's the word I was looking for, to basically insert how the sediment is being taken into account in our model. We're going to use everything as it is. Very let's say standard. So this is going to be a standard. And again, the bed composition parameters, you see that you have the D50, D90, everything is going to be used as standard here, but you basically have everything you want here. This stuff here, output variables, output projection, output advanced options, we're not going to touch them, but the output variables we will put them on later. And these are all the advanced parameters. You can do a bunch of things with XBeach. You can do groundwater penetration. You can insert vegetation through files. You can. This is to calculate. I think. To use different processors. I think, I'm not sure about it, but this is all a bunch of things that you can do if you know what you're doing. But in this case, we just stay with the basics, and then I will show you how to make it a little bit better as a first model. Okay, important is we set things up here. We made the bathymetry. We made sure that the coastal reef model is selected, or whatever bathymetry we want to use. If you imported your bathymetry, you can do that. And then we can make the grid and model. So this is the button we push. And here, this XBeach model is being created. Screen will show up for a little bit. And when it's done, we will see what's coming up with that. Okay, 5 minutes have passed, and this is basically what we have now in the folder. So in the example XBeach folder. So this is a bunch of files they're gonna need by the model to basically to basically run properly. So first you have X and Y, which is these are the components of your grid. So in X and Y you have your grid. You have another way of defining the grid, which is the Delft 3D grid. This we could also delete. It's created, but we're not going to use them. Then you have a params file, a tide file, and a geoswap file, and a bed.dep file. So let's have a look what they are. I'm going to start from the geoswap. The geoswap is this file. So 5.5, 13.4, 107, this is our significant wave height period and wave direction. This is the directional spread, and this is basically the timing, okay, 1 to 3,600. So this is the waves. So from hour 1 to hour 3,600, you have the same wave hitting the shoreline. Good. Then, okay, then we have a tide file. So this is very interesting. This is 1 meter at the beginning and 1 meter at the end. This is actually the storm surge. So the storm surge of 1 meter that you put here. So basically the storm surge, as also could be sea level rise parameters, is given inside here as a tidal level, basically. So we start with the sea level 1 meter higher, we finish with the sea level 1 meter higher, and this is the storm surge. So everything is going to run with 1 meter of surge on top of the normal sea level. And that's the second. The third file, which is very, very, very important, is this one, is the params file. And this is the file where everything that the model needs to know is inserted. So you have everything that the model needs to know. For example, boundary condition file, the waves, you take the geoswap.txt, which is the one we just saw. We give a bed friction Manning, but we doesn't give a Manning value, so it doesn't take into account the bed friction. We're going to see this later. Depth file, take the bed.dep. This contains our bathymetry, the data, the type of boundary conditions, the grid form, which is XBeach, and in fact you have X file, X point GRD, which is this one, and Y file is Y point GRD. The origin is 0 of X and Y. The water level file at the very start is tide.txt, so we start with tide.txt. And what else? The output format is netcdf, so we have a netcdf file as output format, and the start of timing is 3,600, and the stop of timing is the entire model runs for 1 hour. Okay, so this is basically the basics. So this would be a very basic model that you can already run in XBeach. So we're going to try to run this. We're not going to analyze the result, because what I want to do is make another tutorial where you will be able to do something more with Python, include a few more output variables, include a few more details into this model, so you will be able to run a bit of a better model for your first time. But I show you how to run this, how this would basically run already out of the box as we did. This would be very, very simple, you know, beta level, just to see that everything went smoothly. I think we're gonna fail the first time around, and I'm pretty sure why, but I'm gonna show it to you. Before showing you that, I go to the output variables. So these are the inputs that the model needs, and these are the outputs that the model is gonna give you. These are the global variable that you output, and these are the mean variable. It means that every time step you will have these variables out. So this is bed level ZB, this is water level ZS, and you have mean and global. Wave height, U and V are the horizontal the meridional and the eastward-westward velocities. Same you have here. Then you have the sediment erosion, and these two I honestly don't remember. It happens a lot that you don't remember something because the XBeach is huge, and if you don't remember something, you can actually have a look in the XBeach manual. I'm gonna show you how. So you go on Google, XBeach, read the docs, and you get to the XBeach manual. There you go. So the user manual is really huge. You have all the description of every input you can think of. In particular, you have the description of the input parameters. Here, every input parameter is described and every input variable is described. For example, I didn't know what was QX and HH. I can go in Control F and digitize QX in here. It's discharge in new points X component. To be honest, I have no idea what it means, but let's leave it there. And HH is the water depth. Okay, it's the water depth at the different times during the model run. So you see that there's lots. These are all the output parameters that you can think of from XBeach, and you probably will not understand them all. You probably, as I did right now. So SEDERO is the cumulative sedimentation erosion, for example. So this is actually much more than you can dream of, but it also shows you that this is a very widely applicable model. It can be used in many different settings, many different scenarios. If you have vegetation, if you have sediments, if you have discharge of even pollutants, you can do a lot of things with this. It's very versatile. Good. Now we have our parameters file here. This is what I opened up, and you basically have your grid, you have your depth. You can basically even close your Deltares, Delft Dashboard. And what you do is you open up your XBeach here. One thing I like to do is to basically do something like this. I copy this is the model basically, and you just paste it here. This is another very cool thing of XBeach. It can basically be on a USB stick, and this is what you would give to somebody and tell him, okay, run this model without giving them the results already, because the results is going to come up at a few gigabytes. So it might come up as a few gigabytes. So you don't want them to have a huge file. You give them the model, the files, and then it runs. So let's run it. I'm pretty sure it's going to give us an error, and it's going to give me the opportunity to show you how to debug. So let's go there. So this is the folder, example XBeach, where I copied everything. I look for this XBeach and I just double click on it. And you see that it ran for just 1 second. I'm not even sure you saw it. And it gives me this file, which means that there is an error in my model. So I open it up, and it's telling me that it's missing a required value for parameter d theta s. So I'm going to copy this d theta s. I'm not sure why Delft Dashboard doesn't do this, but what it wants is that you have d theta here, and it wants instead d theta s. So this is something I haven't figured out, to be honest, yet, but I think it's something to do with how it's composed. So like this, I just save. Once I save this, I basically changed the parameters inside my model. So I changed what I have inside the model. This is the beauty of it. And then I can go back again. So XBeach here. And now I actually pray that it's working, and it is working. So if it does this, congratulations, you're running your very first XBeach model. So this is solving every equations, every within the grid cells, it's solving every interaction with the waves. And you see that here it's giving me, started at 30 hours, 9 minutes. It's giving me like 50 minutes or something like that. And now I'm gonna let it go. The tutorial is over now. I'm just going to let it go. And what we'll have at the end is a file inside the same folder called xboutput.nc, which is a netcdf file. Why this tutorial is over? Because I just wanted to show you how you create a grid, how you create a depth, so how you put from Delft Dashboard a depth file associated with that grid, and how you create a very simple model. The JSON file, the tide file, this is the basics that you need. What I want to do in the next tutorials is to basically show you how to improve a little bit the model that we already have. So just give it a little bit more, let's say, flavor, a little bit more meaningfulness to for the word, for the real word, and then we rerun it in a better way. It might take a little bit longer, but at least we know that we're not running a very too basic model. Okay, what I want to do is to have you running a model which is sort of usable for a very quick and dirty evaluation. This would be like unusable, so this would be like a very first pass just to see what's going on. Okay, good. So the tutorial is over here. If you got to this point where the XBeach model is running, then you're all set. Then everything is going on. My model is going on. I have 24 minutes remaining, and so this is where we are stopping our tutorial. Congratulations, you just ran your very first hydrodynamic model.